everybody, Mr. Cuddy here, and what I want to talk about today is kind of a tricky factoring technique called factoring by grouping, and it's going to help us graph polynomials better. And this is the last thing we're going to talk about relating to polynomials. It's really going to help complete the picture in terms of us graphing them. Okay. Before we get into anything new, though, I just want to do kind of another practice problem together to make sure we're all good. So it's asking us to sketch a graph of this polynomial by finding the x-intercepts and the y-intercepts, and I want to add one more instruction. I want to add one more instruction, one more direction. I want to use the x-intercepts, I want to use the y-intercept, and I also want to use the end behavior to help us sketch a graph. Okay, so let's start with the x-intercepts. Remember, each factor, we just kind of flip-flop it to figure out the x-intercepts. So since we have x minus 2 as a factor, 2 is an x-intercept. Since we have x plus 4 as a factor, negative 4 is an x-intercept. And since we have x minus 1 as a factor, 1 is an x-intercept. So we have all of our x-intercepts. Next, y-intercept. Just plug in 0 for x. In your calculator, you should get out positive 8. So our y-intercept is positive 8. 0, 8 is our y-intercept. We're going to list out the x-intercepts. I guess we should do that. They're negative 4, 0, 1, 0, and 2, 0. Those are all of our x-intercepts. Okay. The last thing I want to talk about is this end behavior thing. Remember, when we're considering end behavior, we really want to think about the degree of the polynomial and whether the leading coefficient is positive or negative. Now, I know what you're thinking, this polynomial is all factored together, so it's kind of hard to tell what degree it is. But all you have to do is think about the fact that you have 1x, 2x, and 3x's. So if you were to distribute this, aluminum foil it out, the biggest term you'd end up with is an x cubed. You couldn't get next to the fourth or next to the fifth or next to the sixth. So this is a third degree polynomial. The biggest you're going to get out is an x cubed. The other thing we have to consider for end behavior, we have to consider the degree. We also have to consider the leading coefficient and whether it's positive or negative. And we actually don't have to FOIL it all out to figure that out. We can just think about it. If we're going to multiply the x and the x and the x when we distribute, there's not going to be a negative there. There's not even any numbers there. It's just going to be 1x cubed. So the leading coefficient here is 1, which is positive. Now we have to think about an odd degree, because remember 3 is odd, and a positive leading coefficient, what end behavior that has. You should be thinking about that little chart that we filled out together in the last video. Third degree, odd degree polynomial with a positive leading coefficient has end behavior down, up. Okay? So if I asked you what the end behavior is, I don't want to worry about fancy notation. I just want you to be able to say it's down, up. Down, up. Well, that lets you know is that this arrow should go down and the last arrow should go up. And that's going to help make sure that we wiggle through this the right way. So when you're wiggling, and it has to hit there, hit there, hit there, hit there. It's got to end going up, and on the left, it's got to be going down. That's everything we've talked about so far, and I hope you guys are feeling okay about that. We have some time to practice if not, but I want you to be able to do something like that right now. The new thing I want to talk about is related to this idea. What about the form of the equation in that problem makes finding the x-intercepts so easy? Well, it was that it was all factored already. It was beautifully factored out for us. Okay? And let's shut that down. So the reason that last problem was so easy is because it was already factored. If we can get a factored polynomial, we can graph it pretty easily. However, it's not always that easy. It's not always that nice. Sometimes we're going to get polynomials like this, and then we got to do some stuff here. So this polynomial is obviously not factored. There's not even any parentheses. This is in good old-fashioned standard form. It's just like all the terms out together, no parentheses, no nothing. So what we want to do is factor it. Okay? We want to factor it so that it looks like this, because graphing this is easy. Okay? You just did that. So we got to get this factored, and that's going to help us find these x-intercepts. Okay? The way you factor this is going to be something that we haven't talked about. Specifically, notice that we can't use the factoring we've been doing because we have an x cubed, not an x squared. There's 4 terms here, and so we need a new factoring technique. And that new technique is called grouping. Factoring by grouping isn't too bad, okay? Watch this. I'll walk you guys through this one, right? First, it's called grouping because when you got 4 terms, you kind of group together the first 2 and you group together the second 2. And when you look at those 2 that you group together, you take out the greatest common factor of those 2. So if you look at those, you say, hey, what do those both have in common? Well, they both have an x squared. You can take x squared out of both of them. If you take that greatest common factor, that GCF, out of both of those, what are you left with? Well, if you take an x squared out of 2x cubed, you're left with 2x. If you take an x squared out of 3x squared, you're left with 3. Okay? We just took that first group of 2 terms and took a GCF out of them. Next, do the same thing as the second chunk. Okay, look at those 2 guys. What do they have in common? Well, -5. If you were thinking +5, be careful. If this middle one's negative, we should really take out a negative GCF. Okay, I know it's kind of weird, but you can take a 5 out of both those, a -5. If you take a -5 out, what are you left with? You take a -5 out of -10x, you're left with 2x. Take a -5 out of -15, left with a +3. Remember when you're taking out a GCF, you should think about it as kind of like dividing. Like what's -10x divided by -5? 2x. What's -15 divided by -5? 3. And when you're thinking about what a greatest common factor is, you can think about it as what you can divide them both by. Okay? All right, moving forward. What you'll notice, if your grouping is working right, is that this guy and this guy will be the same. And if those are the same, that tells you one of the factors. Okay. So these 2 showing up the same tells you one of the factors. There's going to be another factor, though. And the way to get the other factor is to look at the 2 GCFs you took out and put them together. And now we got it all factored. Again, remember factoring is the opposite process of aluminum foil. It's the opposite of foiling. So if you did this on the test, for instance, or sorry, the learning check, for instance, and you wanted to check that you did your grouping right, you could always just foil it back out, make sure that you ended up getting back to here. I remember the whole purpose of us factoring it was because in the factored form, finding the x-intercepts is easy. Okay? And that's still true, except we got to be a little carefuler. Each factor we're going to set equal to 0. Because remember, that's what we're really doing. It's just that these 2 factors are a little more complicated, so we got to actually do out the algebra. And actually set them equal to 0, do the algebra to figure out the x-intercepts they tell us. Okay, we'll do the right one first. So you set that factor equal to 0, subtract 3 from both sides, divide by 2, you get x equals -1.5. If you solve this one, you guys know how to solve this. Add 5 to both sides. Square root both sides. And don't forget to add the plus or minus. So you get square root of 5 and negative square root of 5. These are the 3 x-intercepts. Okay. Because it was an x cubed function, we probably thought there was going to be 3 x-intercepts, and there was. Okay. How do you get the y-intercept? You just plug in 0 for x. That doesn't change. Okay, so actually, the fact that it's not in factored form to start with, the fact that it's in standard form, is actually kind of nice for finding the y-intercept because you can just grab that last number. Or you can plug in 0 for x, and these will all go away. So your y-intercept ends up being 0, -50. And now you have your y-intercept. You have your 3 x-intercepts, and you can totally sketch a graph. If you're thinking about doing this and you're like, how do you graph square root of 5? You can throw those in negative square root of 5. You can throw those in your calculator. If you throw square root of 5 in your calculator, let me start my calculator up. You get negative 2.2. So when you go to graph them, just kind of estimate where they are. So that one would be at positive 2.2. This one would be at negative 2.2. Okay. I don't want to actually sketch the graph, but you get the idea. All right. I want you to practice this factoring by grouping technique, because being able to do this grouping thing is going to be able to enable you to find x-intercepts when it's not in factored form. So I just want you to do, actually let's do one more together, and then I want you to try one on your own, and then I'll tell you what I want you to do. Okay? Ready? We got 4 terms. We're going to factor it by grouping. We're going to group the first 2 together. We're going to group the second 2 together. And look at those first 2. We're going to say, what can we divide them both by? What do they both have in common? Don't forget, we're going to look at the variable part and the number part. What number can you divide 12 and negative 9 by? 3. What can you divide a cubed and a squared by? A squared. So the greatest common factor is 3a squared. What are you left with? 4a minus 3. If you look at the yellow group, most things don't have anything in common. So what's the factor? Greatest common factor is just 1. And you're left with 4a minus 3. Again, the reason that we know this grouping is working is because these things are the same, and those are going to tell us one factor. And then the 2 GCFs together come together to tell us the other factor. Notice we're just stopping there. We're done with this problem. We did the factoring by grouping part. Why do I want you to know how to do factoring by grouping? Because it's ultimately going to help you find x-intercepts. But the whole part below this line, all this stuff, is just finding x-intercepts after it's factored. For these problems, I just want you to factor them. It's factored, done. Okay? Okay. What I would like you to do is there are 5 more problems here. And I put the answers on the note sheet upside down here. So what I'd like you to do, and I'll just trust that you're going to do this, is after you finish this video, you should do those 5 problems. Do these 5, or check your answers down here, and make sure you got this factoring by grouping down. We'll practice it a little bit, but I'm going to expect that you remember this and that you're able to do this. Cool? All right, that concludes this video. Thanks for watching, guys.